Welcome to the Cosmic Pie Podcast. I'm your host, Wayne Barkhouse, and here with me is
Robert Moore.
We're on episode 20, Robert, of season 2, and we're broadcasting from the campus of the University of North Dakota here in Grand Forks. Quickly mention, we do have a live chat that is running, so if you have any comments or questions that you'd like to make throughout the podcast, please feel free to use that feature. Also, as a disclaimer, we'll get into that right away.
Yeah, we need to do that.
So any of the opinions that Robert and I, or our special guest, which we'll introduce in a second, have to say is our personal opinions and not necessarily the opinions of the university, the state of North Dakota, the United States, the world, the universe, whatever.
Yep.
Cover all our bases just to be on the safe side.
Yep, safe.
So it's my pleasure today to introduce our very special guest, Dr. Ryan Summers, who's an associate professor of science education in the Department of Teaching, Leadership, and Professional Practice here at UND. So welcome, Ryan.
Thank
Welcome.
you. Thank you both for having me.
So today we're going to get into the topic of science literacy. We're also going to cover ground that's related to different state laws that are passed or try to be passed, if you like, that affect everybody who's interested not only in science, but really society in general, as it turns out. So Ryan, do you want to kind of start this process?
Absolutely. So maybe a fair point to start, and I have some slides and things that I can use as visuals here in a moment, but big picture, when we talk about this idea of scientific literacy, it's, it can be defined in different ways, but personally, I really like the definitions that focus on preparing individuals to engage with science in their everyday adult lives, whether that be in civic matters. Do you have to make a decision about healthcare? Can you vote in an informed way about, any kind of legislation that might impact you that deals with science? And so one of the charges, my background is as a high school science teacher, and now I work with pre-service teachers and in-service teachers, is really thinking about how do we prepare individuals who are going to be ready, when they are citizens and adults and making these kinds of choices, getting them to a point where they are scientifically literate. They can at least make sense of, scientific things, and not saying that they can necessarily read technical reports or things like that, but they at least have a grasp of ideas necessary to participate in normal life.
One of the things that's always curious to me is you have a senator, let's say in Washington, D.C., who has to take a vote on some issue. And it's so complicated, right? You're voting sometimes on bills that are thousands of pages long, and there's no way an individual can read through that and understand everything. So they rely on other people, right, to read through the bill to try to find out if there's something that's worth looking at in greater detail, maybe a cause that you would vote no instead of a positive vote. And so you rely on all this extra help, but who's to say that the people you rely on have the background knowledge when it comes to, for example, scientific issues?
Absolutely, and there are numerous issues. I mean, if you were to walk into a doctor's office and seeking medical treatment and just look at pamphlets and things like that, those are usually geared at, a layman, at an individual who just needs to know some of the basics. But it's very easy to find yourself kind of underwater, so to speak, when you are reading, whether it be just a pamphlet on a basic procedure, or when you're trying to interpret test results. Maybe you've had a blood test of some kind. So this idea of scientific literacy can be really tricky, and trying to set a level that we think everyone should get to leads to a lot of discussion. But I think, one of the things that I will share with you in a bit, we have some ideas, and, my scholarship, my background is in this basic idea of how does science work. And I really think it's important for people to know how science happens, how research happens, kind of process and product. And maybe a hope of that is also that they end up trusting science. And that is an important outcome.
Right.
That they can at least know what to question and where to ask for other opinions, things like that. And like you said, we can't expect most individuals to understand everything. Even scientists that are really strong in their discipline don't know other disciplines deeply.
Right.
And
you may not know even, there are aspects of physics that I'm sitting here like, I don't know anything about that, but you get up to a certain level and you're so honed in and focused that your little thing. And even in your own discipline, things can slip by you. So
that's why we have experts, right?
That's why we have experts.
You just got to make sure that the people who make the final judgment, whether it's a vote in Congress or whatever, that they do have expert feedback.
Hmm.
And you also have sometimes, when it's not so clear, if it's an obvious issue, right, like a 0 or a 1, then that's fine. But what happens if it's like a half, like it's a gray area, and therefore you have to use your best judgment to determine if you need to vote on something, positive or negative type of thing. So I think that's where we really get into a lot of, trouble in that sense.
Yep.
And as we've seen in recent years, sometimes the issues are simply complicated. And even if people have very good intentions with whether it be healthcare or personal choices, they may all have really good intentions in mind, but they see the problem slightly differently, and they may not all agree on the path forward. And so, again, having some expert feedback would be really helpful.
Right.
I think for everyday citizens who are maybe hearing about these kinds of conversations on their, whether it be the evening news or if something, an article they read online that's summarizing it, can they kind of piece it together, and can they make some sense of it and feel like they're informed as an individual, especially if there is a place where they get a say in the matter.
Well, I just like to let's leave the cat out of the bag. You ready?
Ready.
Mhm.
Okay.
Let's go.
Vaccines, right? So, since the time of COVID, that's been a major issue. In fact, it's gotten so bad, people literally fight each other over whether vaccines are harmful or not. And vaccines have been around for how many years? Decades and decades and decades. So it's not like it's something new. And we know how to handle vaccines, right? There are methodical trials that are produced. There's statistics that are involved. What's the probability that this particular vaccine is going to prevent you from not only not getting sick, but maybe when you do get sick, that you're not going to wind up in the hospital. And it seemed like we regurgitated all of that stuff from a debate that may have happened almost 100 years ago when this stuff first, or whenever it first started, getting vaccines, that people just didn't have a clue about statistics, right? You'd say, oh, there is a 75% chance that if you receive this vaccine, that you will not get COVID. And then if you get COVID, you're like, well, see, the vaccine didn't work. Yeah, I said a 75% chance. I didn't say there's a 100% chance you wouldn't get COVID. There's also that other 25%. So even basic statistics, right, went out the window. People didn't quite understand what that even means.
Right.
So in some sense, you're trying to teach the public right back from the fundamental levels of pure, thought and deductive reasoning in some sense.
And that really comes back to your original kind of opening around scientific literacy. There are definitely people that out there that would say it's one thing for them to know a certain level of things, but getting individuals to behave in a certain way, maybe that's a different level of scientific literacy, or that's a different outcome, because there are probably a lot of people that academically know some things, but it isn't necessarily then the way they go on to behave. And they
Right.
make choices and we see this all the time. We see people that understand at some level that overuse of alcohol or tobacco or something like that has some negative side effects, but it doesn't necessarily change their behavior. So that link between what they know about a topic doesn't always change how
Yeah.
they behave.
I mean, I'll give a personal example. I ride motorcycles. I know the statistics. I know what they mean, but I still hop on my two wheels and go down the highway,
Mhm.
So, yeah.
Right. And so that's definitely it. And you'll hear kind of like anecdotes, like statistics don't mean much to the individual, but when you definitely see large groups of people behaving in certain ways or being encouraged to behave in a way that doesn't align with maybe what scientists and experts are saying, that does raise some questions.
Right.
Yeah, especially like someone said, what's the probability if it's going to rain today? If I say like 10%, they're like, Yahoo. Okay, individually that affects me because I want to have a birthday party at the park for my children or whatever. And so it depends, exactly what you're talking about, right? If it's that kind of an issue that I just mentioned, then people are fine with that individualized probability of some event occurring. But when it comes in, especially if it's something that for some reason you got a belief, so this is belief versus, knowing facts, and it goes against your belief, and it doesn't matter, that you could say whatever you want, and to convince somebody otherwise, they just ignore you. They put up the blinders, they put up a
Yeah.
wall.
You're going up a hill then.
Yeah.
Mhm.
So,
Anyways, do you want to start showing your slides,
I
Ryan?
sure will.
Interest of time.
And
okay.
And so I've just put together a few things that maybe help us talk through some ideas. A recent article that I wrote and was published online in the conversation focuses on the teaching of scientific theories in U.S. schools and in K-12 classrooms in particular, and definitely how some of this has come under probably more recent conversations in legislation, and there's a history of that over many years, but um, I put this piece together because, as I mentioned earlier, my research, my scholarship, I look at what's called nature of science, and a lot of that has to do with helping people understand how science works in a broad sense, and understanding scientific theories is a part of that.
Oh, Ryan, can I interrupt for a second?
Of course.
So the word theory, I mean, that has led, a lot of difficulties that I noticed, right? I even tried to bring that up on the very first day if I'm teaching like introductory astronomy or some intro science class, is the common usage of the word theory and how a person from a scientific point of view views the word theory. So you always hear this sort of common language that, oh, it's just a theory that, blah, 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 as if there's like no facts or anything that supports it. In fact, people get confused between the actual scientific meaning of theory, in which there's lots of facts that support that initially maybe was an idea, a hypothesis, even a guess. Once you have some facts that lead you down the road to fully understanding what you're trying to develop in terms of maybe some model that explains some part of reality, then with enough facts, it becomes a theory. And then eventually over time, and we can talk about it at some point, then it becomes a law. But the word theory is meant to be, oh, it's just an idea that you have, right? If it's a theory.
Yes. So you actually, Wayne, have introduced a number of pieces of this. So there's one part of it is how do maybe individuals think about the word theory and use it in everyday language versus how a physicist or any other, expert scientist might use that term in their discipline. So that's one piece of that can be really tough around this conversation. There can also be kind of this some challenges with understanding a hierarchy where you think that a theory might have some meaning to it, but is it as sturdy as something like a law? And really one of the things that I try to emphasize, and I have some things to show you as we go on, theories and laws kind of do different things when philosophers of science pick apart different things, like what does a theory do and versus what does a law do? And they're not necessarily rungs on a ladder where one is over the other, and that can lead to some other confusion. And then I'm so glad you used the phrase "it's just a theory," because sometimes all of this can be just thrown to the side and really undermines the science behind it, and how much the durability and like you said, all of the, whether it be the evidence or the repeated results or the things that have gone into this to make it substantial. And when you say something like it's just a theory, it's like saying, it was just an idea and some of these other pieces. So we really have some interesting things to chew on, and I think once we go through, and what I've included in some of these slides is actually some of the language from different pieces of legislation, and we can see how some of this plays out in the wording that they chose to use.
Okay.
Sounds good.
So, and I will definitely again qualify my background on this is in the nature of science, history, and philosophy of science area. I am not a legal scholar, and so to the extent possible, and with respect for space, when I do show legislation, I've tried to show exact wording from different bills and things that I could cite and share. So this is really, if others have other interpretations of this, especially more legal-minded listeners, they would probably be right to have those thoughts and welcome the questions.
Mm-hmm.
So, as Wayne said, this is a quote from Steve Gould that I really like from Evolution as Fact and Theory that just talks about that hierarchical issue.
Okay. So facts and theories are different things, not rungs in a hierarchy of increasing certainty. Facts are the world's data. Theories are the structures of ideas that explain and interpret facts. I can go along with that. And then to me, laws are this works, but we don't know why. Like Kepler's laws of planetary motion.
And typically laws have like an observation, like we can see them, and the
Hmm.
theory might be the explanation for the why. Like the law might be the repeated pattern of observations. Like Kepler, we saw things happening with motion in planetary systems. We know it's happening, but we need a theory to really explain
Right.
what is causing that to be the
And
case. But
and that came along with Newton and the theory of universal gravitation. So
right. And here in this particular book, Stephen Gould, who philosopher but wrote on evolution, the word evolution often gets used as both fact and theory or law and theory. That there is a part of evolution that we see, that we know that organisms change over time. We see that part, and then there's the theory behind it. Kind of that natural selection piece, how it happens. And sometimes people, unfortunately, use the term and mean both or mean one and not the other. So I think this quote is helpful. And there's others that have some really nice quotes to separate the two. But um, to give maybe a good entry point into the legal part of some of this conversation, I think around 2005 is kind of an interesting point. And the reason that I say that is that for decades ago, we had court cases involving the teaching of theories involving evolution and the teaching of specifically of human evolution in the state of Tennessee versus John Scopes. But in 2005, so many decades later, we get this modern example where a school district was essentially charged with teaching intelligent design, and they were trying to prop up intelligent design as a legitimate scientific theory. And they were saying that ninth graders should learn intelligent design right alongside natural selection. And if just to kind of get into that idea is that um, if you want to say from a statistical point of view and things like this, natural selection happened, and then you would have on the other side, intelligent design kind of posits that life is too complex to have developed solely through random evolutionary means. And so they wanted to, they pitched this idea that it was an alternative theory that would maybe explain how we got to the same place.
So, Ryan, when you use the word they, who are you referring to?
Okay, so that's a good point. So in this case, the Dover area school district, they brought this concern up because um, there was a change to the ninth grade biology curriculum, and this took over the town of the area of Dover, Pennsylvania, um, and so there were a number of people, and there's a couple of really good books that chronicle this whole kind of case. But the idea being that they wanted to use a textbook as a supplement to ninth grade biology called Of Pandas and People, and in this textbook it was going to kind of support some of their intelligent design discussion. And so and kind of moving forward with the case, um, we won't go through all the details of the case, but the, ultimately intelligent design kind of got put on trial. Is it a legitimate theory? That was really what happened. And the reason I started with this case is simply to say that the district court judge, John Jones, ruled that, a theory as being a well-tested explanation that unifies a broad range of explanations. And so I think this language that the court introduced at this time is really important, especially when we kind of fast forward to some recent legislation and maybe how they're talking about theories. And so I like this idea as well
So,
because go
sorry,
ahead.
sorry, I was just so the groups that's pushing for this change. That's
Mhm.
kind of what I was getting at with the they. Are these like religious groups? Is this the state government or
So
some? Yeah.
there were the school district was going to use Of Pandas and People. Several families opposed this change, but ultimately, over the course of the hearing, there were numerous religious people and other let's say activists that were involved in this conversation. And so that we had groups that were really trying to pitch that intelligent design was a legitimate theory. And for anyone, that things that I don't have in these slides, there were lots of problems. Like, so for example, some of the books and the evidence that they were trying to supply that would have said intelligent design is its own thing and it's not creationism, well, there were like copy paste errors that showed where they had cut out the word creationism and inserted the word intelligent design, and sometimes there were typos. So like this was clearly some problematic issues, but they really tried to put intelligent design on a pedestal and say, no, it's a legitimate theory, and you all should. And at the time, what was really common in a lot of places dealing with evolution education was an idea of equal time. That if you're going to teach evolution, that's okay, but you should give equal time to some other ideas. And this was an other idea that they tried to frame as a legitimate theory that really did not stand up to the scrutiny of the court.
I mean, if the way I'd be thinking about it is like, oh, you could say all you want about intelligent design, but it's in a religious class. It's not in a science class.
Right, something like that. And it, if you wanted to teach some of those ideas, it could be taught elsewhere. Whether that be if there was a religion class, or if you wanted to teach it in Sunday school or something like that, great, but not a science class. But I think it was a really lengthy decision. I think it's 139 pages that John Jones wrote in his decision, and definitely felt that not only the school and many families were kind of put in an unfortunate situation, and this got a lot of attention, but this was the first time in the United States that we had this kind of issue come before a court like this, and so it really was a landmark case. And so that they were able to show that intelligent design was like creationism that they were trying to teach in the class, or they were encouraging to be taught in a science class. And it's really important to highlight that previous Supreme Court decisions had made it unconstitutional to teach creationism in schools. And so ultimately the plaintiffs were able to successfully argue that intelligent design was really in creationism, and that they had violated the establishment clause of the First Amendment, or essentially the separation between public schools and any kind of state-sponsored religion.
So did a lot of this stuff really happen since Darwin? Is there any record of things before Darwin? Would people try to merge together both religion and science, the way we view things?
That's a good question. I mean, even Darwin himself, and I mean, a lot of people, if they know about Darwin but have never read any of the books, I mean, or kind of looked into his history, Origin of Species really focuses on animals, and there was a big gap between Origin of Species and his next book, Descent of Man, because he wrestled with this idea personally. He had some religious upbringing, and how you would have learned to read and things like that during his time, as an adventuring naturalist. He struggled with this, and so the idea that there might be some conflicts then also between religious views and the wider public. I mean, I think the Copernican revolution is another really powerful example of times when we've seen historically conflicts between what the religious authority might be and what a scientist or someone that was working on scientific ideas might think. So.
Yeah, a lot of the stuff we know is based on our senses, right? You mentioned Copernicus. So if I was standing outside at night and nobody told me anything about astronomy, I would assume the Earth was completely at rest because I don't feel any motion at all with my senses. And that everything I see in the sky, the stars and the planets, all go around the Earth. And in the daytime, I can see the sun going around the Earth. That's a natural sort of model you get just by using your senses. But our senses can be fooled. The Earth is moving, and it's doing multiple motions at the same time. And that's where we get down into the deductive reasoning, which is, at the heart of the scientific progress, coming up with observations and some idea that eventually reaches to the stage of theories where we can not only explain everything around us, but also we can explain something that happens that otherwise we didn't know about. For example, the one thing I like to use is Galileo. When Galileo first looked at Venus through his telescope, he saw it went through a series of phases. Mm-hmm. And not only that, any time that Venus displayed a crescent phase, it was the largest in apparent size. And any time that it was nearly full Venus, it was the smallest in apparent size. So here's an absolutely new observation that nobody knew about prior to Galileo. And if you test it on both the Copernican model and the geocentric model, the Copernican model wins. You don't have to do anything to the model at all. So that's the beauty. Not only can you predict things with a theory,
And
But the
that's,
other thing is you can actually explain something like new observations or new experiments that nobody had ever thought about doing prior.
yeah, that, and
Absolutely.
that's something that one of our viewers brought up is that science generally has predictive power. And
Yes.
so somebody else is asking, how about homeschoolers teaching creationism along with evolution? And my response to that, y'all may disagree, but what they do in their own home is their business.
Right.
What
And
we
and and
do
you
as
know,
government is a complete different matter.
Well, I'd
right.
argue if we're at home, sorry, Ryan, to cut you off, but if we're at home, I would say, okay, now it's time for religion class or philosophy class. Then
Right.
you teach it. Now where it's time, because, at home, you're all the subjects together, right, from the
Right.
same individual. Now it's time for science, like biology, and now we're teaching evolution. Ryan, it's at the point now where in my astronomy class, sometimes I'll talk about like galaxy evolution, so I'm not talking about a living thing. And I always have this bad taste in my mouth when I use the word evolution
Hmm.
because of all the baggage that comes with that.
And you're right. There is baggage, and what, even if we don't go into the how would we approach it in homeschool, just reminding folks that are listening in, and maybe, um, you know, education is a states' right issue in the United States. So even we do not approach like, a massive kind of, we don't have a ministry of education. We have at the federal level we have a department of education, and they may encourage certain things, but education remains a states' right issue, and that's why some of the points that we'll talk out in specific cases are really important. One of the reasons that we do have standards for education is that we hope that students, whether they be in North Dakota, we hope they get the same quality education as they might get in Colorado or in Maine or anywhere else. We want students to be able to move across the country and move around and have a similar quality of education. And so when certain states are maybe talking about changing science education in ways that could really be harmful, it's worth our attention,
Yeah, because otherwise you're playing whack-a-mole, all 50 states, right?
right?
Yep.
So I'll just pull up, to give folks an idea of the kinds of changes then we're talking about, is that here are a couple examples, kind of in that era from after the Dover trial, through about 2019. And so Louisiana passed the Science Education Act, and Tennessee also passed a House bill, which was later signed into law in 2012. And they're both similar in certain ways. Both of them, rather than advocating for equal time of different ideas to be entertained in a classroom, instead they use this language that focuses on discussion of scientific theories, or the Tennessee bill further specifies discussing the strengths and scientific weaknesses of existing theories. So talk about strengths and weaknesses. And so both of these bills have that became laws, have very similar language. And it's fair to point out that there was a bill introduced in North Dakota in 2019, but it was withdrawn, that would have been very similar in language as well.
Now, the part, Ryan, about teaching, if you like, the weaknesses and strengths of scientific theory, that's a natural thing we do in science class.
It
Yeah.
is.
For example, in my astronomy class, getting back to that, we teach about the Big Bang, and I can talk about, the four major pieces of evidence that support the Big Bang theory, but there's also weaknesses, and in fact, that leads to the introduction of the inflationary hypothesis that adds to the Big Bang. So that as a scientist, you're always looking, in fact, it's funner to look for the weaknesses, right? If you think
Right.
about particle physics, you read about, the particle physicists running experiments, always trying to look for something beyond the standard model of particle physics because they're looking for weaknesses. Because that hopefully will allow you to construct an even better theory eventually.
Right. I mean,
Absolutely.
I've brought up the point to students before that, scientists, you don't make your career by following along with the crowd. You make your career by busting up what we supposedly knew. That's when you actually do something, is when something you've done shows, well, we were wrong here. If you're just following along with the crowd, nobody will ever know what you did.
I guess that highlighted for the Tennessee House bill was that an attempt by somebody to force in things like intelligent design, but in retrospect, at least from a scientist's point of view, We agree with that. That's exactly what we try to do. And I think whoever wrote the bill, now maybe I'm wrong, probably wasn't thinking the way we're thinking.
Right.
And that's the concern that and kind of I don't have a specific quote from one individual, but across all of these, the general concern that opponents would voice is that this kind of language could open the door for teachers or conversations or even kind of encouragement to challenge scientific theories even when there's no controversy, as far as most of the scientific community you know at a certain level agrees on evolution, agrees on global climate change, and even human impacts as parts of it. Like, they agree at certain levels of generalization about what's going on in some of these places, and the fear is that these strengths and weaknesses kinds of conversations allow for weaknesses to be introduced that don't reflect the current consensus in the scientific community.
Right.
Yeah, I always have trouble with the word like belief.
Right.
Because somebody would ask me, do you believe in this? Do you believe in that? And I said, I don't believe in anything. I look at the evidence to see that, okay, chances are it seems to be correct. And someone could even say, oh, it's like the movie Contact. I don't know if you've ever seen that, Matthew McConaughey. And there's a line in there, do you believe that your father loved you, or something like that? And he goes, prove it, type of thing. And someone would say, do you believe that your spouse loves you? And I'd say, I don't believe in anything. You don't believe that? No, I look for the evidence. Number one, when I come home at night after work, she's still in the house. She didn't leave me. All these kind of things,
That's
right? So there's all these facts or pieces of evidence, these observations that I make that show me, that she still loves me. This kind of thing when I'm talking about my wife, right? It's not a belief, right? There has to be hard evidence.
Right.
Absolutely.
Yeah.
So, kind of getting back to some of the idea that we introduced at the beginning, I mean, this is straight out of Merriam-Webster, kind of the dictionary, that this it's only a theory kind of language unfortunately does have some roots in kind of common use of the word theory in everyday language, whether it be conjecture rather, or speculation. And that definitely differs from that first definition that's listed, that definitely seems a lot more scientific. And so there are just some of the challenges that we wrestle with when we see these kinds of laws start to appear, or discussion of the legislation. Well, from an outside perspective, like you said, Wayne, there might be people working on these kinds of bills that don't think of this in the same way that we're talking about some of these issues. So it could be, unfortunately, from this kind of naive perspective around what does theory mean in science.
Right.
Yeah, if the dictionary's wrong, and everybody's going to quote the dictionary, right? They run to that.
Right. Well,
and go ahead.
I was just going to say that there is a difference in how the word is used. Absolutely. And people don't want to accept that a lot of times, that, in science, when we say a theory, that's what we're after. Mm-hmm. It's not a guess. It's not a speculation. It's, here's some facts. This is what ties them all together. Mm-hmm. And yeah.
And I think, Robert, that really kind of leans into this slide is nothing more than just sometimes the way that students see science. And this is true across K-12. And I'm going to argue it's probably true across most of, undergraduate students, especially if they're just taking a couple of science courses to fill essential studies requirements. They see kind of a really clean version of science, that they go in, maybe do labs, and the lab is already kind of known for them. They're not discovering anything new. They're not in those areas that Wayne described, like particle physics, really challenging an existing theory. They kind of get this sterilized version of how science happens. And so maybe it makes sense that they don't leave with a real good sense of what theory really means, because they never were the ones testing them, or that they get a lot of what I would say is like some of the simple, how kind of baking brownies version of science, like, can you follow instructions and get something, versus like, let's wrestle with what other scientists got, what the literature says, things like that.
Well, when I was coming up in the early 70s, we were taught that scientific theory was an educated guess. And it's like, I know part of the problem there is that people didn't take away the educated part. They took away the guess part of that. And we also have a question. Have you commented on the need for criteria to define a theory versus some other structure? Wayne commented on part of this, also testability and so on. How about those criteria? And we're kind of getting into that.
Yeah, and I've got two slides here and coming up. I'll show you kind of what the current language is that a lot of states are using to guide science instruction, like what we hope students will kind of come away with. And then I've also got a slightly different list of theory criteria that I commonly use when doing research. And so, and that I think is pretty popular among science education researchers. So yes, that's a great question.
Okay.
So here is that language. This is from how Nature of Science is talked about in what are called the next generation science standards. These were written in 2013. Um, this is kind of the current reform document for K-12 science education. So it's, two documents that came out in 2012 and 2013. North Dakota adopted these standards in 2019, and so this is not the whole piece on Nature of Science, but for the sake of space, I clipped out the part about science models, laws, mechanisms, and theories, and their role in explaining natural phenomena. So you can kind of see how they're supposed to build in ideas across from kindergarten through high school. And even if we don't argue about when students start learning some of these ideas, I really do like the kind of those 5 big points that we hope students should know by the end of high school.
Yeah, I was reading through some of those, and they're good ideas at least.
Mhm.
So
Yeah, right. And I think in terms of ideas, and really these standards continue to encourage that students learn this through engaging with science ideas, like not just, read about it in a book and maybe take a test, but, hopefully students get a chance to do a little bit of work and then understand maybe how a theory was developed, and or understand the role of a model, like how a theory can act as a model. And we talked about earlier, like it can help us make predictions, whether it's Kepler or other ideas, like how can these theories act as models and help us to either make predictions or help us to find questions that we want to investigate.
right.
And
A
yeah.
lot of this, Ryan, is really common sense when you boil it down to the nitty gritty.
It is, but it's hard to communicate, and sometimes, you know like you said, so many of these things get used differently in everyday language. I fear that sometimes, even if we're taught well, it would be very easy for us to slip into bad habits.
I just,
For students that were great science students that really picked it up, but a few years down the road, maybe they don't have a whole lot of other formal science after high school or after a couple college courses, and then they slip into some less than good habits in thinking about this.
well, I'm thinking like a young person who's not contaminated by facts. That is, we haven't had the chance to spoil their minds by telling them everything and let them tell us what they think about their environment. You put them out in a field, a grass field in the summertime, and they run across a flower that's yellow. Let's say it's a daisy or something. And you ask them, why is it that color? Why isn't it something else? You get down this road of basically, and not, it's common sense in a way, but it's just like, what is your inquisitive nature of just being human means? And you
Right.
go through this thought process of trying to understand around you. I mean, everybody does that, right? It's like, think of thousands of years ago when people had a god of thunder, right? A god of lightning, and all this to try to explain things that they just couldn't wrap their minds around what was the cause of all that, cause and effect type of stuff, right? But in some, then we contaminate humans by then putting them in a school system, for better or worse, to learn these facts, and we kind of take away, in some sense, when they get older, that desire as a young child to try to understand everything around you, right? So how many people actually go into science when they leave high school? Not a lot, right? How many of you were curious when you were 5 years old? Almost everybody puts up their hand. So between the age of 5 and the age of 17 or 18 when they leave high school, something happened to them.
Well,
Carl
they
Sagan has a great quote to that effect.
yeah,
What happens between those years.
and
And
the answer for a lot of people is that they've been taught that science is a bunch of equations, and as I like to term it, it's not 100% true, but I like to term it a bunch of rich dead white guys who said these things, whether they're true or not, they've never investigated. You know, and that's what science is.
so I will say, for anyone that's listening and that's interested in what else maybe is included aside from theories in this nature of science category, um, you definitely can find this document. It's called Appendix H of the Next Generation Science Standards. Just to Robert's point, one of the other categories that they kind of lay out this same way is called science as a human endeavor. And it talks about that really science is done by diverse people, things like
Mm-hmm.
that, and really trying to help students understand that um, it isn't just, a lot of people graduate high school, they can name Einstein, they can name Newton, but they don't know a whole lot of the diversity of science and scientists that have existed. So I think that is something that folks are trying to change.
Right. I
Um,
mean, let's bring out the province of Chandrasekhar and all these other people and folks.
Well, the
I
other thing
agree.
too is, as scientists, we make mistakes because we are human beings.
Right.
mhm.
But science is a self-correcting process, right? Everybody's checking your work, and if you want to get criticized for what you do day after day, be a scientist.
Be a scientist.
And that's a good thing because we're making sure that things are done as far as we could tell in the right way. And it may put us back for several years for whatever reason because we didn't have the experiments or we didn't make the fine-tuned observations that we need to make, so we were kind of led down the wrong road. But eventually we turn around and start going on what we think is the right road. So it is like, and we're humans, and that happens all the time, right? So
Yep.
Oh, Wayne, you're really getting into a lot of other good pieces that I hope people leave K-12 with, like understanding why peer review is important and how scientists really do work as a whole community. You work within your discipline to make the science better. And that often that involves criticism and that involves reviewer number two and whatever else that. But we hope that people understand that that this isn't like if you've ever watched like a movie like Young Frankenstein that can give you really different ideas about science, or you've ever thought about the lone survivor scientist who is able to save the world by themselves, that's really not how science works.
It's not.
So um
well, think of
so
the other thing, Ryan. That's kind of unfortunately back in the early 90s, everything looked good, but now it doesn't look so good. And that was the invention of the atomic bomb.
Yeah. And
and yeah.
yeah, you bring up something. You brought up several points there, reviewer two. And I encourage people to go out. There's several websites about the things reviewer two says. There's a reason we're commenting on that because
Yeah.
it's usually one of your reviewers when you do peer review that just absolutely shred what you did.
Yeah. And just to kind of bring this around, like you know we discuss and discourse, but sometimes students, learners, they see a fraction of that. And so this quote from Abdel Halak in 2012, I really like, that talks about that students maybe hear about competing scientific theories, and that's how textbooks are written and things like that, and they get so much into the conflict and the kind of that part of it, they don't remember or don't focus as much on that theories help explain, they offer predictive power, they generate research ideas and things like that. And so I think this is just like really shows the maybe a direction that we continue to push towards in our science teaching to help learners learn about what theories do for us.
I
And
always
so
think,
this is, I was just going to say,
yeah,
this is a list that I use in research. But Wayne, I welcome your comments.
I was just going to say, in some sense, a theory is almost like a chapter summary of the book of life, where
Yeah.
we try to make sense of what we see around us. That's human beings. We're trying to make sense of everything, our environment, if you like.
Hmm.
And then that's where it is. You go through life trying to make sense of things, and these theories can be we think of as a generalized chapter in our knowledge base, and we trying to hang all this stuff together to understand everything that's out there.
Mm-hmm. I like this definition, by the way. I mean, yeah.
So these are definitions I've in the past I've looked at, like state science standards, and kind of looked with this lens on, like, are we trying to communicate these ideas? I've also looked at textbooks, and so try to say, are textbooks hitting on these ideas and things like that. And so that's some of my other scholarship that have used these
Mm-hmm.
definitions. But I'll before we get back into the maybe more recent legal challenges, I feel like I have to say, I think for a lot of people, and we've definitely talked about it here tonight. I think using the history of science is a really good way to show students scientific theories, because sometimes they don't get a chance to interact with them. And so there's a whole team at Texas A&M They have a project called Story Behind the Science, and they pull together kind of real science stories, and then they highlight some of these complicated issues, and they talk about like theory development and things like that. Um, and so this was linked in my article in the conversation. Um, I think it's one way that we can help learners understand theories. And these were all developed for the undergraduate level. I believe their team is working on some for the high school level.
Nice.
But it really is, whether it be Kepler, whether it be Copernicus, there are some historical stories that can be used really well to help teach some of the, to meet those standards or to work toward those definitions of theories.
The other thing I think, Ryan, is, there obviously the world has many countries, and the different countries can control their own education.
Mm-hmm.
What about a country that, it's strictly scientific, like doesn't have the debate of trying to move off of, different ways of teaching science and want to incorporate things that should be maybe in a religion or a philosophy class, so on and so forth? Those societies that don't go down that road, right? They strict with the scientific method and keep plowing away. At the end of it all, it seems like those are going to be the countries that may develop into the superpowers of the future.
It's definitely a thought. I mean, there are a lot of belief systems. I mean, when you talk about if you were to open up this conversation with new students, the idea of like what is science and what does it do, and then the things that science doesn't do, but maybe that belongs to religion or philosophy. And if we were able to have that conversation a little more upfront, I think it would really be helpful. Sometimes some of the issues that have come up in this legislation so far, and it'll come up again here in a moment, teachers sometimes, especially in K-12, get into a place where they don't feel like they can say anything, or they don't feel like they can say what they think is right because they're concerned about the ramifications.
Right.
And that's like, I think what you're getting at, Wayne, is that we definitely have some conflict between religious and scientific views, and we don't have a good way to say what gets taught where.
No,
We have people with feelings about where it should be taught.
right, and if we spin our wheels too much, then we can watch other people from other countries pass us by.
Right.
And there will be the ones that will develop, quantum computers and the next generation of AI, if you want to use current buzzwords or whatever it is in the future. And then they wonder, well, they look at us and say, okay, why is the United States falling behind in science literacy, for example?
I wonder.
Here is $10 billion to fix that problem. No, it's not money, right? Money can't fix everything.
That is definitely a question. And so I've got a couple examples of some very recent, I would say even these are some ongoing discussions in legislation. And these were some of the ones that we called attention to in the conversation article, and I've been able to expand here a little bit. This is Oklahoma's Senate Bill 140. And again, we see this same language around strengths and weaknesses of existing theories.
Yeah, but I mean, I could spin that in a positive, right? You should do that.
You should.
I'm glad you said that, Wayne, because then what I'm going to do is I'm going to show you here is, one part of it as written says that it can't be construed to promote any religious or non-religious doctrine, but quotes from the bill's sponsor maybe tilt in a different direction.
Should be able to. Yeah.
That's in the bottom right.
Yeah. By allowing alternate views to be presented. There we go.
Now, you can, so I could argue this, Ryan, just play devil's advocate. Okay, so we have, evolution. But if I propose something else that's different enough, so I would not call it evolution, but it's a scientific idea that's based on some evidence already, and maybe it's just nurturing, it's a nugget or a grain of an idea that I am trying to promote, has nothing to do with supernatural anything, then we should look at that. Just like we do any other ideas that came along that eventually may end up replacing a paradigm shift in our understanding of the way we think about things.
If you have that evidence and that predictive power, I agree.
Yeah, I don't like, I don't know if people say this, but I assume it's actually thought about, that you scientists, right? You're like cement, right? You get stuck on an idea and you get hardened in your views, and forever there's no way, even if we come out with evidence galore that says that that theory is wrong, that you somehow are wasting your whole career up to that point doing work related to that theory. And now it turns out that was all a waste of time in some sense, but it really wasn't, because that's how theories go from one to another, is that we realize there's something wrong here, something's missing, we
Right.
can't explain. And but that's not the way science works. As a good scientist, I might spend 20 years working on string theory, and then some evidence comes along that says that string theory is incorrect. Then you drop it like a hot potato and you move on.
Black swan.
Yeah, and there are, I think there's a couple pieces of that. Like, if there was evidence, and depending on where it was at, like Robert said, kind of how confident we were, maybe then we'd be having a conversation. But I mean, I'll remind the audience that when I put this together, it was really focused on these are directed at K-12 schools. So if there's often cutting edge science that doesn't make it into K-12 school curriculum, just for how long it takes to be put into textbooks and things like that. Like, there are things that will get there eventually if they're worth it. But
Right.
on the other hand, there are some episodes in history of science where some people have really clung on to beliefs and fought for things maybe longer than they should have, and some things like that. And so sometimes it is a difficult process. And for that reason too, a little time isn't necessarily bad. But here's another kind of example, which I think kind of gets into the devil's advocacy here. And this is Montana Senate Bill 235, which was also introduced in 2023. And so they really, in this bill, and I think what makes it worth discussing, is that they try to separate what is meant by a fact and to focus on the idea that we should only teach facts, and theory should just all not be in K-12. So
Wow.
And that's, I mean, at that point, it's like you got total chaos, because I could present a whole bunch of facts which may or may not be interrelated with each other. And if you don't have that chapter summary, as I was alluding to, the theory, that try to make logical sense of it, then it's exactly what I said. It's just chaos.
Right. It's just a bunch of disjointed information. Wow.
and I'm gonna say, like, this is a highlight example. Um, you know, when this particular one, there's a lot of footage of publicly available footage of the open hearing, and this is truthfully the case. And this is another really important function of science educators as advocates. Whether it be state science standards or a bill like this comes up for public comment, they tend to show up in force. And so there were science teachers and students who spoke against this, and they rightfully pointed out that if that kind of bill was passed with that language, scientific theories like atomic theory and cell theory, things that are well substantiated and taught across K-12 and into, undergraduate and studies and beyond, all of that would be cut out of K-12 simply because it was a theory. And that just, it's very difficult to contemplate the consequences of that
Wow.
kind of language and legislation.
Well, I could think of students in K-12 thinking, when I get older and go into university or do whatever, I'm going to stay away from science completely because it's a mess.
Right.
Right? There's no organization to the structure of all if you're not allowed to introduce theories and that in that sense. So why even bother go there? And the other thing I want to say before I forget, I don't want to be a teacher in these states.
Right.
Because your job is on the line. You do the right thing and you can be put down so easily just by a flip of the meaning of one word might sink your career after, being in the business for 20 or 30 years.
I'm just looking at this list and going, atomic theory is speculation. Really? Give up your cell phone. Stop using computers. Don't drive an automobile.
And maybe one of the challenges that teachers in K-12 settings face, because like Wayne talking about, like, particle, anyone doing particle research or high energy research, there's just certain things that we can't replicate and show them in K-12. Like, to be able to show them atomic theory, we don't have the lab equipment for that. Or, it's just, when you think about these kinds of things, like, could I show them evidence that might support these theories? Absolutely. But certain things,
Right.
and then that doesn't even talk about how we know what we know about things like geologic time and continental drift, things that really are very different to test and or in Wayne in your wheelhouse, cosmology. We can't replicate cosmology in the classroom.
Right.
That's why we try to use the best use of computers to simulate things.
Hmm.
So based on what known facts and the interrelationships between those facts, and then here's the simulation. And you could, in some sense, some of that responsibility falls on us, people in higher education. That we're not. I mean, what's the job of a professor, right? You do your service commitment to your department, to your college, to your university, to your community, to your country, and so on. And then you do the teaching aspect, and then you do your research. But I don't ever see an opening where it's like, okay, your job, maybe as a science educator, but I'm talking about someone who's an expert in the various disciplines. As you, as a chemist, for example, come up with some ideas with your chemistry colleagues where we can demonstrate this sort of effect at the K-12 level.
Right.
And there's not yeah.
I had a conversation last year with someone from chemistry that wanted to talk about how we could use lasers, and I said I think the simple answer is going to be they're going to tell you not to. It's just a safety. It's very the lab equipment, things that we could do in undergraduate labs is not the same as what we can do in a middle school or high school classroom, and that's just that is what it is.
Well,
So
I just told some students today that, we ask a question of what for uniformly accelerated motion, what if your motion is better fit by a cubic of third power equation? And my response was to point out, you're not ready for that because the answer is the acceleration wasn't constant. Or that may be one of the answers, possible answers. You're not ready for that.
yeah.
And so there's some of this stuff that we could get into the discussion, but they may not be ready for it. They may not have the framework to even understand what you're saying.
Mm-hmm. So it just this is definitely another example, kind of like the very beginning, sharing with all of you that um, laws that get into the details of defining what is a theory or court case rulings that have defined are really specific. And I think a lot of listeners, maybe even if you follow education or you follow science, maybe you didn't realize that how specific some of this language has gotten. And then the last example that I'm going to share this evening is this is this is an ongoing discussion. So this is West Virginia Senate bill that was just passed in March. And so you can see that it definitely comes back full circle, that saying that under this bill, teachers could teach intelligent design, and they've gone so far. The ACLU in West Virginia has kind of set up a tool to help parents and families really monitor closely what's happening in schools. So this is another bill that's really open to the idea is that schools should be able to talk to and not be blocked from teaching about the origins of the universe. So Wayne, cosmology, they want to give teachers some support if they want to talk about the origins of the universe. And sponsors of the bill have commented that this definitely could allow them to teach intelligent design or other things. And so this has gotten some added legal attention, and activists have kind of really been monitoring this case.
I don't want Ryan. I don't understand the word intelligent design. It's God theory. Why don't you just come out and say what they mean? Why beat around the bushes?
Right.
I think if you were to hear it pitched, things like the examples that they commonly use are take like an insect eye, something that has like this really complicated biological feature. And then if you take, on the other hand, like a scientific argument that said, everything kind of came down to random probability to get here, someone would say, oh, that eye is too magnificent and complex. And so that the idea that there had to be an intelligent hand behind the scenes that curated this sequence of changes and events. But you're right. I think previous cases have demonstrated that intelligent design, as it is often used, is a proxy for creationism.
Yeah. Well, I think, Ryan, thank you very much. Looks like we're at the end of our hour.
Yep.
That's perfectly fine. I'll put this up there. If you're interested in these kinds of cases, I'm going to just say that National Center for Science Education monitors this kind of legislation across the country. You can search by state, but Robert, Wayne, thank you so much for having me here this evening.
Thank you for coming on.
Yeah, thank you very much. And so maybe hopefully we get you back another time because there's still lots more to talk about.
Absolutely.
So
Sounds great.
Our next podcast is next Tuesday, October the 1st. And we always leave you with a quote. So today's quote is by a former NASA astronaut, Mae Jemison. And she says, "Science literacy isn't about figuring out how to solve equations like E equals mc squared. Rather, it's about being able to read an article in the newspaper about the environment, about healthcare, and figuring out how to vote on it. It's about being able to prepare a nutritious meals. It's about being able to think your way through the day."
Yep.
So thank you very much for
Thank you.
listening.
And I guess we're out.